Hello everyone. This video is on the Knewton Alta assignment, section 3.1, part 4, called one-to-one functions. So in this video I'm going to be doing a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions you see when you work on the assignment yourself, but the objectives are all the same, so the questions should be similar, and I'm hoping that watching me go over them, these here help you in some way when you do it yourself. Alright, so your assignment page should have the title up top, the mastery bar. You should be able to see your objectives, right? It looks like there are 2 objectives for this particular assignment. And then beneath the current objective, there should be a question related to that objective, and at the bottom of every question, you should see a feedback button, right, where you can send feedback to Knewton if you wish. You will not have this instructor cheat button. Right? This is for instructors only. But you will have a more instruction button. So you click on this if you're struggling with a topic. It'll take you to a page with some reading or some videos or both. And then you'll have some questions related to that instruction, and you can get through the assignment by going to more instruction and working on those questions every single time if you wish. Okay. So the first objective that I'm looking at here is use the horizontal line test to identify one-to-one functions. Now we've seen the vertical line test earlier in this section. I think it was section 3.1 part 1. Now the vertical line test told you if y was a function of x. It just told you if a relation was a function, period. The horizontal line test will tell you if a function is one-to-one, right? So this is even more specialized. All right, so before I get into this question, let me talk about what does it mean for a function to be one-to-one. Alright, so remember, a function, every value in the domain goes with exactly one value in the range. Right? Every input goes to exactly one output. Well, a one-to-one function not only has that property, but also the other way around. It's a function, right? It's a function, so every input goes to exactly one output, in which each value of the range is mapped to, or corresponds with, or whatever, is mapped to by exactly one value of the domain. So not only is every input going to every one output, but every output is gone to by exactly one input. So some examples here. So say here's the domain and range of some function. If this element in the domain went to this, and this went to this, and this went to this as well, this is a function. It's a function, but it's not one-to-one because of this element here. See alright, so this is again domain and range, inputs and outputs. See, every input goes to one output, so it's a function, but not every output has just one input going to it, right? This output here has 2 inputs, more than one input going to it, so it's not one-to-one. But if I change it up a bit, right? So again, here's domain, here's range, elements here, if this was the case, this input goes to that output, this input goes to that output, and this input goes to that output. This is a function, right? Because every input's going to one output, but it is also a one-to-one function because every output is gone to by exactly one input. Right? So it's both ways. Every input goes to one output, and every output has just one input that goes to it, not two or three like this guy up here. Right? Now, this particular objective I'm looking at first talks about the horizontal line test. So I'm assuming you remember the vertical line test. So let me talk about the horizontal line test. This is to determine if a function is one-to-one. This is determine if a function is one-to-one. Alright, so first you would use the vertical line test to see if the graph even represents a function in the first place. Because if it doesn't represent a function, then it can't be a one-to-one function, right? In order to be a one-to-one function, you have to be a function first. Alright, so I'm going to put up two examples here of functions, alright, graphs that represent functions, y as a function of x. So here's one, just a simple line, linear function. And then, here's a little parabola, right, but still a function. Right? These still pass the vertical line test. Right? They pass the vertical line test, so they are representing functions. But are they representing one-to-one functions? So every x goes to one y in this graph, right? Because it is a function. But is it the other way around? If I pick a y value, does it go to exactly one x value? So that means the horizontal lines. Every y value is on a horizontal line, right? And if you look at every horizontal line on this graph, it's hitting the graph one time. Right, it hits the graph once. So I'll say there will be some graphs of one-to-one functions where the graph, there's like horizontal lines that don't hit the graph at all. Right? But here's the first part. If every horizontal line hits the graph at most once, so one time or no times, at most once, then y is a one-to-one function of x. Then you do have a graph that represents a one-to-one function. Okay, so this is like the beginning part one of the horizontal line test. All right, but it's got to be every horizontal line hits the graph at most once. All right, so over here we have a function, right? Passes the vertical line test. This is y is a function of x. Every x goes to one y here. Every value in the domain goes to one value in the range, whatever. But if you pick, say this value of y here, you see how it's going to, it corresponds to two different inputs, this one here and this one here. So this y value is on this horizontal line, right? If I draw a horizontal line, and you see it hits the graph in more than one place. And that's all you need to show that a function is not one-to-one. Just find one horizontal line, just one, that hits the graph more than once, and that tells me there's an output with more than one input going to it. All right. So if all you need to do is find one. If a horizontal line hits the graph more than once. That's two words, more than once. Then not one-to-one function. Then the graph does not represent a one-to-one function. Does not represent a one-to-one function. Okay, it passes the vertical line test. It's a function. It's just not a one-to-one function, right? It's not that special kind of function. All right. So I'm hoping it's clear the difference between these. Okay, so back to the assignment problem. So they're asking, which of the following graphs show a function that is also one-to-one? All right. So see, this one passes the vertical line test. It's a function, but it doesn't pass the horizontal line test, right? See, I can draw a horizontal line here, go left to right. That hits this graph more than once. So that means there's some outputs that get mapped to by more than one input. That does not happen in a one-to-one function. So that's not being checked. This one, vertical line test, so it's a function, and horizontal line test is also passed. Every horizontal line I draw hits this graph one time or no times, but never hits it more than once. So that graph does represent a one-to-one function. Here, it's a function, passes the vertical line test, but look at this horizontal line here. I can draw a horizontal line right here, and that hits the graph 3 times. If you can find a horizontal line that hits the graph more than once, that means that there are outputs that are mapped to by more than one input, and that again does not happen in a one-to-one function, so I'm not checking this one. Here, function, passes the vertical line test, and then if I go left and right, left and right, left and right, left and right, I'm only hitting the graph one time, every time. This passes the horizontal line test. This represents a one-to-one function. And that's all. And then submit. And then after you submit a problem, right, it'll tell you if you're right or wrong. And then it'll give you some answer explanations. All right. Please look over the answer explanations, read through them, especially if you got it wrong, just to make sure you understand why you got something wrong so you can maybe fix something in the future. Learn from your mistakes. All right, so moving on. All right, now we're in the other objective. Just determine whether a function is one-to-one. So again, now here they gave us a table, just a list of ordered pairs. Remember, x's are the inputs, y's are the outputs, right? X's are from the domain, y's are from the range here, y's. Now, first they're asking, determine whether y is a function of x. Just first, it has to be a function first before it can be a one-to-one function. I hope you understand this. So look, every input is going to one output, right? There are no repeating x values. 5 goes to 7, 0 goes to 6, -5 goes to 7, 6 goes to 1, -4 goes to 5, right? All the inputs go to exactly one output. So it is a function. But now, is it one-to-one? Does the other way around happen? No. See, there's 7 and 7 in the y coordinates? There's an output of 7 that gets mapped to by two different inputs, right? Two different inputs go to the same output. That does not happen in a one-to-one function. So it's a function. Every input goes to an output, exactly one output. But it's not one-to-one, right? Not every output is mapped to by just one input, right? The output of 7 is mapped to by two different inputs. So yes, it is a function, but it's not one-to-one, this option here. And again, please read through the answer explanations. Okay, back to the horizontal line test. So same thing here. See, this one passes both the vertical and horizontal line tests, right? Every horizontal line I draw will hit this graph one time or no times. So it's a one-to-one function. Here, there's a horizontal line that hits this twice. So not one-to-one, not clicking it. Here, every horizontal line hits it just one time. This is a one-to-one function. Here I can see a horizontal line that hits this twice, not one-to-one. Great. Okay, next question. All right, again, back to just a simple table. Now this one isn't even a function. Do you see the x value of 3 showing up twice? 3 maps to 14 and to -3. You have an input that goes to more than one output. That's not even happening in a function. So I'm just simply saying y is not a function of x. You don't even need to check if it's a one-to-one function, if it's not even a function in the first place. Okay. All right, then again, now it's not a table, it's just a chart or a list of ordered pairs. Remember though, the x coordinates are the inputs. So -2, 7, 1, 2, and 7 again. I'm seeing two ordered pairs here with the same input. And look, that input is going to two different outputs. You have 7 goes to -5 and -4. You have an input that goes to more than one output. That's not a function. So it can't even be a one-to-one function. Right? I don't even need to check the other way around. It's just not a function, period. All right, same thing again. Here, again. Wow. So, 0, see the input of 0 has an output of 1 and 6. The input of 0 goes to two different outputs. This is not even a function. All right. Now, if 0, 6 wasn't there, it would be a function, and then I would go backwards and say, hey, okay, now that it's a function, does every y value go to just one x value, right? Because that's going to happen in a one-to-one function. But this isn't even a function again, right? The relation is not a function because you have an input going to more than one output. All right, great. So that objective's done. And then we're just doing the horizontal line test again. All right, all that's left is the horizontal line test. So here, every horizontal line hits this one time. That's a one-to-one function. Here, there's a horizontal line I see that would hit this 3 times. That's not one-to-one. Here, I see a horizontal line that would hit this twice, so it's not one-to-one. Here, every horizontal line hits it once. And also it passes the vertical line test, so it's a function and a one-to-one function. Click on that. Great. All right, again, these should be pretty simple, I think. All these are pretty easy, I think. And then here, I see a horizontal line which hits it 3 times, so not one-to-one. Here, every horizontal line I draw would hit it 0 times or 1 time, so this is one-to-one. Here I see a horizontal line that would hit it twice, so not one-to-one. And here, every single horizontal line I draw would hit it only 1 time, so this is one-to-one. All right. So yeah, these should be pretty simple, I feel, right? Just, is it a function, right? Does every x coordinate go to exactly one y coordinate? And then if it is, then check the other way around. Does every y coordinate go with exactly one x coordinate? And if that's the case, then the function is also one-to-one. Simple, simple. All right, and that should be it for the preview version of this assignment. As I said at the top of the video, please know that the questions I saw here may not be the same questions that you see, but the objectives are the same. The problems should be similar. So I'm hoping that watching me do these here helps you out in some way, when you're working on it on your own. And thank you very much for watching.